In this video, we're going to cover linear and literal equations. By the end, I'm expecting you to be able to do two different things. First of all, I want you to be able to answer the question, how are equations solved using properties of equality? And secondly, how are absolute value equations solved using properties of equality? Let's start with just some basic definitions. A first-degree equation is an equation where the highest exponent is 1. So all linear equations are considered first-degree equations. And also the equation of a straight line is a first-degree equation. Here's an example for you. 3x plus 5 equals 6. That's a first-degree equation because if you look at the x, we don't see an exponent. And remember, when you don't see an exponent, it means there's a 1 there. When we solve a first-degree equation, we're undoing the order of operations. So recall that the order of operations, please excuse my dear Aunt Sally, says to first do parentheses and then exponents, do multiplication and division in order from left to right, and addition and subtraction in order from left to right. So if I'm undoing that, if I'm going the opposite direction and solving the equation, then the first thing that we have to undo is the addition or subtraction. And then the next thing that we'll undo is the multiplication or division. Let's do some examples. Let's first do the 3x minus 17 equals 0. When I solve a first-degree equation, I draw a straight line down from the equal sign. First thing we have to undo is the addition or subtraction. That's located here. So what undoes subtraction? Addition will undo that. And notice if I add 17 to both sides of the equation, negative 17 plus 17 actually becomes 0. That's often a step that we don't write in, but that's actually what's happening there. So 3x minus 0 is just 3x. And then your next step would be to divide both sides by 3. So x equals 17/3. Let's look at the next one. The next example is 4x plus 15 equals 2. So let's draw our line down. We have a positive 15 or a plus 15 happening here. So what undoes that? Subtraction. So now we've got 4x on the left. I'm not going to include the plus 0 this time. And you have to be able to add and subtract integers. So 2 minus 15 is going to give us negative 13. Next step is to divide both sides by 4. So x equals negative 13/4. The last example from the previous slide was 3 times the quantity x minus 5 equals 1. Now, since most of you don't like dealing with fractions, which is what you'll end up with if you immediately divide by 3, I suggest go ahead and distribute the 3 and go from there. So we've got 3x minus 15 equals 1. And then we're going to do what we've done in the other examples. Add 15 to both sides. There's my equal sign. So we've got 3x equals 16. And then divide both sides by 3. So x is equal to 16/3. Now in each of these examples, if it's a solution, you should be able to plug these answers back in and end up with a true statement. And I highly encourage you to do that. That's good mathematical practice. And it's also going to ensure that you have the answer correct. Let's do one more like the ones that we've done, and then we'll do some that has some more parentheses in it. So you can see here we would still just add 5 to both sides. 3p is equal to 24, and then you would have to divide both sides by by 3, and you would end up with p is equal to 8. Now the example below is a little bit more complicated, mainly because of the parentheses, but we also have a variable on both sides. So let's go ahead and write that on a fresh page. Okay, so let's start by using the distributive property. So I'm going to distribute the 3 and also the 2. So we end up with 3m minus 18 plus 2m minus 8 equals 4m minus 2. Let's clean up what's on the left-hand side of that equal sign. So we've got 3m and a positive 2m. So altogether that gives us 5m. And I've got a negative 18 and a negative 8, so we've got negative 26. Now I need all my variables to be on one side and all of the constants to be on another. I generally always just move the variables to the left and the constants to the right. That way there aren't so many different scenarios I have to think of. So I'm going to go ahead and subtract 4m from each side. Remember that 0 idea. 4m minus 4m makes that 0. It's gone now. Over here we just have 1m. And over here we've got negative 2. Last step, add 26 to both sides. So 1m is equal to 24, or m is equal to 24. When working with fractions, my suggestion is to multiply through by a common denominator and eliminate the fraction. So if we look at the first example here, 2 and 4 both go into 4. So I suggest multiplying this entire equation by 4. And if I multiply both sides of the equation, it remains equivalent. So I've got 4 times x over 2 and 4 times x over 4. Now 4 times x over 2 gives us 4x over 2, or simply 2x. And 4 times x over 4 gives us 4x over 4, or just x. And 6 times 4 is going to give us 24. So let's rewrite this. We've got 2x minus x equals 24, or x is equal to 24. Let's do that on this second example. Let's put that on a fresh slide by itself. Now these are some pretty nasty looking fractions. So rather than dealing with the fractions, let's figure out what 10, 15, 20, and 5 all go into. And you'll notice that they all go into 60. So we're going to multiply every single term you see here by 60. I don't expect you to write each of them out. If you can do them in your head without showing the work, that's fine. I'm just going to show it for those who need it. So we have r over 10 times 60, which is 60r over 10, or just 6r. We have 60 times 2 over 15, and remember that can cross out and become a 1. This can cross out and become a 4, and 4 times 2 is 8. We have 3r over 20 times 60 over 1. That can become a 1, and that can become a 3. So we've got 9r. And then we've got 1 over 5 times 60 over 1. And that can become a 1, and that can become a 12. So that's just simply 12. So let's rewrite this nasty looking equation. It ends up with 6r minus 8 equals 9r minus 12. A whole lot easier to solve. Let's go ahead and do that. So I'm going to draw that line down from my equal sign, and let's move the 9r to the left. So we've got negative 3r minus 8 equals negative 12. Let's add 8 to both sides. So we've got negative 3r equals negative 4. And then we've got to divide both sides by negative 3. Now be careful with this, guys. You really have to watch your sign. We've got a negative over a negative, which is going to become a positive. So r is actually equal to positive 4/3. Let's move on just a little bit to absolute value. Remember, absolute value is a distance that a number is from 0. So if I have the absolute value of negative 4, it's 4 because that's 4 units from 0. Or the absolute value of 4 is also 4 because that's 4 units from 0. So think about if I want to know the absolute value of something is 4. Then that something has to be either 4 or negative 4. So in order to solve an absolute value equation, drop your absolute value signs and then set each equal to the positive and the negative. Here's an example of that. If we have 2h minus 1 with the absolute value, and we know that that's equal to 5, to solve this, I'm going to drop the absolute value bars, set it equal to 5, and then in my other equation, set it equal to negative 5. You'll go through and solve these, and you'll actually end up with 2 answers. Let's look at some literal equations. A literal equation is an equation where there's all variables involved. So if I have PV equals K, and we want to solve it for V, I'm going to use all the steps that we've developed up to this point. If V is the one that I want, then I've got to get rid of P somehow. You got to ask yourself, well, what's the operation between P and V? In this case, it's multiplication because we don't see a sign. So if I divide by P, then those P's will go away, and we end up with V is equal to K over P. The hardest part about this is being okay with the fact that you're not going to have a number as an answer. Let's look at the other example. I is equal to P R T. If T is the variable that I want, I got to get rid of the P and the R. Again, we've got multiplication going on. So if we divide by PR, then we're going to end up with I divided by PR is equal to T. Let's examine how a first-degree equation presents in application problems. So let's suppose that Juan has received $52,000 from selling some land. He invests part at 5% and the rest at 4%. And he makes a total of $2,290 in interest per year. How much did he invest at each rate? Let's make a table for this. We know that we've got a 5% interest rate, and we know we've got a 4% interest rate. Now, we don't know how much he invests at 5%, so we'll call that X. Now, how much he invests at 4% is going to be how much he's got left over after he invested at 5%. So we started with $52,000. If X of it went to the 5%, then we've got 52,000 minus X left to invest at 4%. Now let's figure out how much he actually makes from each of those. So if I've invested something at 5%, then 0.05 times X is how much money I'll actually make off of it. And likewise, 400ths times 52,000 minus X is how much I'll make off of the 4%. And I know what that total is supposed to be. That total is supposed to be 2,290. So boy, oh boy, do we have a big equation now. Let's go ahead and put that on a new slide. I'm not one who likes to deal with decimals very much, so I'm going to go ahead and multiply through by 100 so that I don't have a decimal point. When I multiply through by 100, that's going to slide the decimal over, and we're going to have to tack on 2 zeros there. So now we've got 5x plus 4. The parentheses protected that piece of it. And then we've got to go through and clean this up. So we've got 5x plus 208,000 minus 4x equals 229,000. The 5x minus the 4x becomes 1x. And we've got to subtract both sides. With that 208,000. So it appears as though x is equal to 21,000. So if you think back, that x was how much was invested at 5%. So how much was left over to invest at 4%? 52,000 minus 21,000, or 31,000. This next problem on gasoline octane mixing is similar to the previous slide, but a little bit different information's been given. We've got a 94 octane gasoline that's going to be mixed with 200 liters of a 99 octane gasoline, and we know the total is a 97 octane gasoline. So what's different here is what's given. We know the amount of the 99 octane. That's 200. We don't know the amount of the 94 octane. That's x. We know the total here is going to be the x plus the 200. So similar to how the previous problem worked with the interest rates, the octane of a fuel works the same way in that you multiply them. So we've got 94x plus the 99 octane times 200 liters of it, and that should equal the 97 octane, and we know the total is going to be x plus 200. So let's go through and clean this up and simplify. Alrighty, so we've got 94x. Using your calculator, if you multiply 99 by 200, you'll get 19,800. And then if we multiply 97 by 200, you'll get 19,400. And now let's do some cleaning up. Let's go ahead and move the 97x to the left, because we've stayed pretty consistent in moving that direction. I don't want to confuse you. We do get a negative. That's okay, because I'm going to end up getting a negative when I subtract this 19,800 and move that to the right. So over here, we end up with negative 400. When we divide both sides by negative 3, I'm good because a negative divided by a negative becomes a positive. So x is 400/3. I'd like for you to take what you've learned so far and do some of the practice problems in MyLabs Plus. We will take some time to meet to do some more problems like this and talk if you need to on any of the word problems or anything we've covered so far. Go ahead and check announcements, check emails, and get up to date on any future meetings that we might be having.